Okay, good afternoon, everybody, and welcome to FDL 2017, NASA's Frontier Development Lab, which has been an 8-week summer research accelerator for PhD level students doing work in machine learning, artificial intelligence, together with their counterparts in astrophysics, planetary science, video physics, and more. So this is a program conceived at NASA, at the Office of the Chief Technologist, and we're in our second year here. This is a program which not only is designed to demonstrate the efficacy of applying machine learning resources and capabilities to deep science and basic research questions, but also an exercise in public-private partnership of increasing importance to the government and indeed to private enterprises like Intel, who's been kind enough to let us use this beautiful facility today to host this event. So I have just a couple of remarks that I want to share. A mere 15 pages, should get through this shortly before we get underway. But I want to say it's been really a privilege to host this event at the SETI Institute from its inception last year to the expanded program that we had this year, which is culminating in today's event. I'll speak more about our partners and sponsors, and my colleague James will be talking about them as well. But when we get to the award ceremony at the end of the program. But first of all, I'd really like to thank James Parr of Trillium and his colleague Sarah Jennings. Where is she? Sarah is waving in the back, and the Institute's and the SETI Institute's own Debbie Collier. This team of three, with lots of other support from the Institute and from Trillium, has just done an incredible job in putting this program together. Basically, without their efforts, really from program inception and structure and content through to the kickoff, the boot camp, and the main event, today's wrap-up session has been truly extraordinary. So thank you, James, Sarah, Debbie, and all our colleagues at the SETI Institute and at Trillium for putting this together. Finally, before we get fully underway, I want to say how personally honored, this is a comment coming from me personally, to be here at Intel in this beautiful auditorium, not only because of Intel's involvement and sponsorship in FDL, but also because of the leadership of Intel CEO Brian Kuzanich, otherwise basically known as BK here at Intel, in taking a strong stand against hate groups, racial injustice, gender and identity intolerance, and inequality. It's interesting because when you work for an organization like the SETI Institute, where we really work to study the origins and nature of life in the universe and the evolution of intelligence, and you run programs like the FDL, you get a lot of appreciation for the island that is planet Earth and that we all call home. As the dominant species of the planet, we have a responsibility to deal with the daunting challenges we face for our own survival that are largely of our own making. We'll only succeed if we face these challenges together. We frankly have no time for hate, for injustice, or for inequality. We have work to do. And with that, let's get the work underway. I'd like to turn this over to my colleague, James Parr. Thanks, Bill. Good job.
I really hope you guys like math, because we have some math for you today. This is a quote which really you shouldn't use in presentations. Any significantly advanced technology is indistinguishable from magic. However, the stuff we've seen, the work we've seen over the past 8 weeks, the application of these emerging AI technologies to problems in the space sciences is getting pretty close. And I'm really looking forward to sharing with you today. But the magic's not just about the technology. The magic's about the people. Our teams are a mixture of planetary scientists and a mixture of data scientists and folks in machine learning. And we brought them together only really 7.5 weeks ago to tackle these really difficult problems in the space sciences. The first problem, this is a bit high, isn't it? Do that. The first problem is looking at long period comets. So these are comets which really go deep into our solar system, out beyond the planets, and really quite difficult for us to see. And so one of our teams took on the daunting challenge of seeing what we could do to find these objects. The second team, also a planetary fence problem, is looking at radar shape modeling. So this is looking at near-Earth asteroids as they go past the Earth, and we get a chance to take a little peek of these objects and see what they look like. And so the team applied these emerging technologies to see if we could get a better understanding of their shape and spin and other features. We also have two problems from heliophysics. So we have a team looking at solar storm prediction and all the activities that are happening on the surface of the sun, stuff that can particularly affect Earth in terms of interference from solar flares and other events. And then also from heliophysics, solar terrestrial interactions, so the effect of the Earth's relationship with the sun and all of the different forms of data we can collect from that relationship. We also had a team looking at lunar water and volatiles, so this tantalizing possibility which they'll go into about the fact that our closest satellite does actually have resources that could be used for furthering our next steps into the solar system. And we also have a team looking at AI itself and what is the potential for artificial intelligence in the space sciences. So that's our agenda for today. We're going to have the teams come up and present this work to you, and then we're going to have a break at 2:45. We're tight for time, so if you can just sort of, if you need to do a break, please leave the auditorium. But if you don't, just stay in here and we'll keep the drumbeat going. And then at 4:15, we'll have a panel discussion where we really start to discuss some of the themes that are emerging from the work you'll see here today. So just quickly before we kick off, I wanted to say thank you to our amazing partners. FDL is a public-private partnership between NASA and the private sector. It's fairly unique in this regard. And of course, we couldn't do it without our private sector partners. The data, this isn't cat photos. Space data is massive. It's multi-dimensional. In fact, I saw a presentation yesterday and the comment was, could you just redo that graph? And someone said, I could, but it has 64 billion data points. This is big stuff. And we couldn't do this work with the sort of accelerated time frame that we use for FDL if we didn't have support of the private sector. So I'd like to thank Intel, who were instrumental in the Lunar project, IBM, NVIDIA, KX, who were instrumental in the Helio and planetary defense projects, our friends at LOCKHEED Martin, and of course, Space Resources Luxembourg, who really helped, and you'll see when the team present their work, is a fantastic result that will benefit both government work and private sector work. So thanks so much to our partners. I think the last point I'd make on that is we need this resource because we need to iterate quickly. So rather than take 2 weeks to get a result, our teams are able to get results in hours or even overnight. So you imagine when you're innovating and you're testing algorithms, you want to be able to learn, pivot, try something else. And so the ability to have that capability given by the private sector is a huge benefit to us. And I just want to say thank you. In fact, probably deserves a round of applause for that. And last but not least, NASA, which of course gives us these fantastic problems to work on. You had the wisdom to let's have a go, and also to let us experiment and grow. And second year in, so FDL is now 2 years old, and I think we're showing that we're figuring out how to do this sort of research in very accelerated time periods using this combination of skills that we're bringing to bear. And also, of course, our amazing, awe-inspiring researchers. I was trying to find a way of describing just how smart this group is. And I was thinking, well, if you could measure intelligence and gravity, you could describe them as being particularly dense, but I'm not sure if that sort of works. But it is awe-inspiring. They are, as I said, a mixture of data scientists and planetary scientists that started fresh 7 weeks ago. And so I think when you see the work, you'll be like, how did they ramp up so quickly? It's extraordinary what they've done. But also, on that point, they are presenting at Intel in Silicon Valley to NASA. And I can tell you that is extremely intimidating. And so when they come up, I really want you to give them a really big, warm welcome and really encourage them because they've done phenomenal work and I'm very proud of what they've done. So without further ado, I think we might kick off with the first presentation. So can I ask the long period comments team to come up? And whilst you're coming up, I'm going to introduce our panel. Unfortunately, Yuhel and Kim can't make it, but we've got Pete Warden, who's he's here.
He's here now.
Oh, excellent! Thanks for joining. Oh, nice to see you. So we have Pete as well. We have Ian Goodfellow, and perhaps actually if you guys stand up and just introduce or say hi to the audience. Don't have to say anything. From Google Brain, Gert Berenson from NASA Kepler. Jesse Dotson from NASA ATAT, which is the Asteroid Threat Assessment Team, and Victoria Friedenson from NASA PDCO, Planetary Defense Coordination Office. So with that, I'll hand it over to our comments team, and we have a hashtag, you'll see hashtag FTL 2017, and of course our Twitter handle is at NASA_FTL. So good luck guys, and take it away.